All right, for every surface, every nice calculus surface at least, at all the points where it's nice calculus-wise, meaning kind of smooth, you can find the tangent plane. We have to be able to do it with surfaces that are parameterized by two variables. For example, u squared, v squared, u plus 2v. Don't know what that surface looks like, but it's okay. If the question is formulated correctly, that point should lie on the surface. So first we can figure out what values of u and v do that. Well, u squared has to be 1, so u equals 1, and v squared has to be 2, so v equals 2. And let's just quickly check. If u equals 1 and v equals 2, then this third coordinate is 1 plus 2 times 2, which is certainly 5. Okay, cool. That point lies on the surface, and we know where. Okay, now, so let's call this r. We can find the partial derivative of r with respect to u, and that is 2u comma 0 comma 1. So we're looking at these as direction vectors in uv space, basically. And we can find the partial derivative of r with respect to v. So that's going to be 0, 2v, comma 2. And now, if we put in these points into these vectors in uv space, so at u comma v equals 1 comma 2, then r of u is 2, 0, 1, and r of v is 0, 4, 2. Then these are two vectors that are going to lie in that tangent plane. So the tangent plane is now a plane passing through the point 1, 4, 5 with these two vectors lying in the plane. So if you want, you can write it, and actually I always like to scale the vectors down if I can. So I don't like 0, 4, 2. I'm going to write 0, 2, 1. Doesn't matter. This is no longer r sub v, but it's still a vector in the plane. So if I want, I can actually write it in two-variable parameterized format. It depends on what the question asks for. So I could go start at 1, 4, 5, add a scalar multiple of 2, 0, 1, so plus 2. Let's use new variables s and t, so that we have plus 0s here, so I won't write it, plus 1s here. And then over here we have plus 0t, plus 2t, plus 1t. I'm going to use this other vector here. Okay, so that is an answer to the question. They didn't tell us what format to do it in. We found the tangent plane. Or if you want to do it good old Math 126 style, 2, 0, 1, 0, 2, 1, we can find the normal vector. I'll just do this quickly, as negative 2, negative 2, and 4. I'm going to scale this down and make fewer negative signs. So if I divide through by negative 2, it's 1, 1, negative 2. There's the normal vector. So then my plane can have format x plus y minus 2z, and then I'm going to sub in the point 1, 4, 5 equals 1 plus 4 minus 2 times 5, which is negative 5. X plus y minus 2z equals negative 5. And that is the same plane as the one we found here, just in a different format.